Hi, this is Dr. John Bergduff. In this video, we are going to use truth tables to determine whether a logical argument is valid. The example I want to show you is fairly involved. It's going to involve three component statements. Here's the argument I want to look at. If some journalists learn about the attack, then they will post the news online. If the news is posted online, then the attack will not be a secret. The attack was a secret. Therefore, no journalists learned about the attack. We want to determine if this is a valid argument. In order to use the tool of a truth table, we're going to first have to translate this argument from English into symbolic form. Doing so will involve or include identifying the component statements that are part of this overall statement. And I see several here. Let me define them for you. First of all, I see the statement that some journalists learn about the attack. Let's call that statement P. Some journalists learn about the attack. Second component statement that I see here is they will post the news online. Let's call that Q. They post the news online. And then I also see the statement that the attack will not be a secret. Remember that we like our statements to be positive statements, not involving words like not. So let's say that R is that the attack was a secret. And so if we want to say that the attack was not a secret, we'll simply use a negation. Let's translate this argument step by step. So the first statement is an if-then statement. It says, if some journalists learn about the attack, then they will post the news online. That can be written as a simple implication, a conditional statement, if P then Q, or P implies Q. The second statement is also an if-then statement. If the news is posted online, then the attack will not be a secret. So if the news is posted online, then the attack will not be a secret, so we want to refer to that as the negation of R. And finally, we have the statement that the attack was a secret. That involves a simple, single component statement that the attack was a secret. That is nothing more than an R. These statements that we have so far are what we would refer to as the premises. The premises lead to a conclusion at the therefore. Let's see what the therefore is. We'll use this little symbol for therefore, very traditional symbol. The conclusion is no journalists learned about the attack. That would be the negation of some journalists learned about the attack, so that would be negation of P. And that would be our conclusion. This is the argument written in symbolic form. Now, if I want to analyze whether the argument is valid or not, I can create a truth table based on the conjunction of the premises leads to the conclusion. If this statement and this statement and this statement, then this statement. If I state that entire thing symbolically, it would look something like this. It's a giant if-then statement including all the premises. P implies Q, and Q implies not R, and R. If all of those premises are true, then the conclusion, and the conclusion is not P. So we will write a truth table involving P, Q, and R and examine this statement right here. I've recopied the statement just for convenience, but let's go ahead and now create the truth table. Because there are three component statements, we will need columns for all three, for P, for Q, and for R. By order of operations, negations come next, and I see a couple of those. Let's make a column for not P and not R. And then as we examine this overall statement, remember that parentheses mean do this first. So let's look at a column for P implies Q, Q implies not R. And then we'll begin to put it together. Remember, we do conjunctions from left to right, so we would first do P implies Q and Q implies not R. Then we could do P implies Q and Q implies not R and R. And finally, in the interest of space we're running out of, we would be able to look at the entire statement, which I will just put right here. Let's make columns here so everything is very clear. Column for P, column for Q, column for R, not P, not R, P implies Q, Q implies not R, P implies Q and Q implies not R, P implies Q and Q implies not R, and then finally the overall statement, which there was no space to write. And there are 8 possible combinations of truth values between P, Q, and R. The easiest way to do that is to make the following table, or the following pattern. Under the P, write 4 trues, followed by 4 falses. Under the Q, write 2 trues, followed by 2 false, followed by 2 true, followed by 2 false. And under the R, alternate true, false, true, false, true, false, true, false. This gives you every possible combination of truth value for P, Q, and R. And now we can begin to build our truth table. Now, negation of P will simply just reverse all the truth values for P, from P. So the negation of P, that column would look like false, 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 true, 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 true. Not R, again, look at the R column, reverse everything, false, true, reverse all the truth values, false, true, false, true, false, true, false, true. Now we'll have a conditional statement. If P, then Q. Remember that conditional statements are only false when the first statement is true and the second statement is false. It may be useful to mark the columns that you're looking at just so you don't lose track of where you are. So we'd be looking at P and Q. And in the first case, we have true followed by true, so that's true. True followed by true is true. True followed by false, that's the one situation that's false. True followed by false comes again. False followed by true is true. False followed by true is true. False followed by false is false. And false, false also gives me true. In the next column, we're again looking at an if-then statement, but this time the columns we're interested in are Q and not R. We'll have to be very careful as we get a little bit farther into the table to make sure we keep our columns straight. So in this case, our first row, we're going to have a true followed by a false. That's exactly the situation where you get a false. Then you have a true followed by a true. That's true. And then a false followed by a false. That's true. Because again, only when a true is followed by a false is a conditional false. Then a false followed by a false, that makes it true. True followed by true is true. True followed by true is true. False followed by false is true, and false followed by true is true. So false, and then the remainder of that column is true. Oh, I may have a mistake right here, if you see it. I did miss a place where there was a true followed by a false right here. True followed by false. That one would be, in fact, false. Sorry about that. Now, in our next column, we're looking at a conjunction, and it's a conjunction of the 2 columns we just have most recently created. Let's mark those in green. And remember here that for a conjunction, for an and statement to be true, both component statements must be true. Let's check it out. So we have a false and a false. That's a false. We have a true and a true. That's exactly where we would have a true. And then we have a false and a true. That's not good enough. That's a false. False followed by true is also false. True followed by false is also false. Two trues makes a true. And in fact, we got three of those. So we have a true, and a true. Next, and I'll need another color, we will be looking at the column we just created and the column for R way back over here. Again, it's a conjunction, so it's an and statement. Both statements have to be true for the statement to be true. Let's check this out. So first, looking at the purple columns, I'd have a true and a false. That would be a false. And then a false and a true, that would be a false. And a true and a false, still a false. And a false and a false, still a false. A true and a false, well, that's still false. Lots of false here. Followed by a true and a true, finally. We end up, wait, let me just make sure here. We have, a false, a false followed by a true, false and a true, that would still be false. Then we have a true and a true. Here's my true and a true. That will result in a true. And finally a false and a true, that's false. So there's only one true in that whole column. Now the final column is a massive if-then statement. If the conjunction of all the premises, then the conclusion. I need one more color. Let's use blue. I need to look at this column, implies this one. Very, very important to do this one right, because in this case, this is our first statement, and this is our second statement. So we want to be very careful about this. A true followed by a false will give a false. Let's see if we have that anywhere. So we have a false followed by a false. That would be a true. We'll stay in blue here. A false followed by false is still a true. Actually, if the condition of, if the first statement in the conditional statement is false, you know you're going to have a true. Doesn't matter. So this is a true, this is a true, this is a true, this is a true. Let's look at this one very carefully. We would have a true followed by a true. That's a true. And finally, a false followed by a true is a true. Now, this is exactly what you want to happen. When you build your truth table, the final column should be a tautology. A tautology is a statement in which the final column is all true. That means this is true no matter what the initial conditions are, and that means that our argument is valid. A list of all truths in the final column tells you have a valid argument. And I hope that was very helpful.